Hello, I'm Rodney Harrington. I'm the CEO of Aqua Research. We've developed a stream system, we call it, for treating and making disinfectant for drinking water, for healthcare settings, for orphanages, for lots of different applications where a disinfectant is needed to make water safe or to keep surfaces clean. The system is very robust. It operates primarily on a little electrical power and some salt, common salt, just about any kind of salt. Operates on any type of power, 110, 220, solar panel system like this, or car battery. In any event, we will describe the operation of this system and the maintenance for user to be able to operate this thing effectively. So the key components in the stream system are the control box, the brine pump to transfer brine from the brine tank to the chlorine tank, an oxidant electrolytic cell that converts the salt water to a disinfectant solution, which is primarily chlorine, a power supply that converts the power down to the correct voltage to operate the system. It includes power cables, it includes hoses for transferring the fluid via the pump from the saltwater tank to the disinfectant tank. It includes charts for mixing the saltwater solution, the brine solution, as well as charts for dosing the disinfectant into the water you want to treat, whether it's drinking water or for surface cleaning or for other applications. We also have a storage compartment for measuring cups and pipettes and other devices for dosing according to the charts. So the stream system operates very simply on salt, and a little bit of water and electricity, and it makes chlorine solution, sodium hypochlorite, and a little bit of hydrogen peroxide to make this disinfectant very effective. This technology was developed under government contracts for the military initially, and it has been applied now both commercially and in low-income settings and medical settings and things like that. We begin the process by collecting 2 buckets. Both of these are 5-gallon buckets, 20 liters, and it doesn't make any difference if they're this size or smaller or larger, but you want the disinfectant bucket to be larger than the brine bucket, because when this thing is running, you don't want it to overfill the volume of a smaller disinfectant bucket. So the next step is to remove the wires and the hoses from the bundle. We have Velcro straps, make it very easy. This is the power cord for operating 12 volts from a car battery or solar panel. And then another hose set for connecting up the saltwater brine feed and the disinfectant. And they are connected at the center with a connector. We continue by disconnecting the 2 hoses. One is a small hose, 1/4 inch, and one is a 3/8 hose. The small hose goes in the brine tank, and the large hose with the connector goes into the disinfectant tank. We then continue by removing the pre-filter from the storage container that's in the case here. You remove the pre-filter, connect the hose to the end, and this pre-filter is a porous polypropylene filter that filters out dirt and things that may be in the salt. It has a stainless steel collar to weight this down in the saltwater tank so it doesn't float. So you begin by determining how much salt you're going to be adding to the water that will be used to make up the salt water or the brine. In this case, we have about 5 gallons of water. You look up the chart, we need about 150 to 200 milliliters of salt. The amount of salt can vary a little bit from the chart. It's okay, the system will correct. But in any event, you begin by filling this cup with salt, and you then put that in the water that you're going to make the saltwater solution with. Just about any kind of salt can be used to make up the saltwater solution that we're going to be using. It can be crystal salt, rock salt that's used in water softeners. It can be food grade salt. It can be dirty rock salt. It's not important as long as it is sodium chloride type salt. So you pour the salt in the container to the volume you need that we determined from the chart, and you get ready to pour that in the water. So you pour the salt into the water tank that's going to make up the saltwater solution or the brine, and then you stir it. with a stir stick, any type of stir stick. You can use your hand to stir it, but you want to stir it until you no longer see any salt in the bottom of the tank. You want it completely dissolved. So you simply put the filter in the bucket and let it float to the bottom. You place the larger 3/8 hose with the connector fitting attached into the disinfectant bucket. If you don't have a 110 or 220 line power source, you can operate this on a car battery or other 12-volt source such as a solar panel system. So to do that, you simply disconnect the main power cable here from the power supply and connect up the alternate 12-volt power lead directly to the connector. After the 12-volt power cable is connected, you simply undo the power cord Velcro strap again, and then you take these leads and connect them to the positive and negative terminals of a battery or a solar panel system. The next step is to turn the system on with the push button start switch. That will start the pump running, and it will fill up the brine hose from the brine tank. It will fill up the electrolytic cell and continue flowing into the oxidant tank. And this has to get stable before the control system comes on and starts monitoring the amperage settings in the cell to make sure the disinfectant solution is the right concentration. So the brine pump is a peristaltic pump. It's a very simple pump, and it controls the speed of the fluid through the electrolytic cell. If the amperage in the cell is high, then the brine pump will speed up a little bit more to get the concentration of the disinfectant going to the day tank correct at 5,000 parts per million. If the amperage on the cell is too low, then the brine pump will slow down so that the brine resides longer in the cell and gets up to 5,000 parts per million before it goes into the oxidant storage tank. So the start switch has a LED, and it's a multicolor LED, green, orange, and red. If everything is running properly, the light will be green. If the orange light comes on and it's blinking, then it may be a low battery or high brine problem. And then you connect the battery properly or add water to the brine. If the battery is low, you'll have a solid orange light that comes on. You just have to correct the power source. If you have a blinking red, orange, red, it means the voltage from the power source is out of range. You need to correct the voltage source. If the red light is blinking, then you have too much salt in the brine solution, or the tank is empty. If it's a solid red light, then the salt concentration in the brine tank is too low. If the system is operating or overheating, then we have a red, green, red light flashing. If the system overheats, where you have the red, green, red flashing light on the control panel, you will be measuring temperature in the fitting here that measures the temperature of the disinfectant. If it gets too hot, then that alarm will go off and light up. In that case, it may be that there is restriction in the tubing or that the brine has run out. There's another scenario that operates as well. You will occasionally see the brine pump stop and then start and running again. And then a few seconds later it'll stop and start running again. That occurs when the control system is cleaning the electrolytic cell. There's a special circuit in here that creates a process in the cell to keep calcium carbonate scale from forming in the cell. So you run the system until the brine tank is empty. And when it's empty, the system will automatically stop. For a 5-gallon container, 20 liters of brine solution, the system will run about 4 hours before it drains the tank. You'll note that when the brine tank empties that the light turns red. Basically, it's low on salt. It's out of salt water. So the alarm system will come on and light the light switch here red. To turn off the system, you simply push the button. So one of the faults that may occur is that the brine has been made with too much salt. If that occurs, then the light will begin blinking and stop the system. The solution to that is simply add more water to the brine tank to dilute the salt back down so it's in the right range. After we've made the disinfectant solution, then we dose it. And there are typically three scenarios that we want to use the disinfectant for. One is for simple drinking water from lake, river, stream, other source of fresh water that you want to treat to kill the microorganisms. The second scenario is surface cleaning in a medical setting or around the house. And the third is for a highly contaminated environment like that may have occurred in Liberia during the Ebola crisis. So you gather the parts in the bag, and this is a chlorine test strip, and we gather a syringe to measure the disinfectant, or a pipette, a small, very small pipette for very small volumes, like anything less than a gallon or so. Next, we are going to go to the dosing chart. In this dosing chart, it will set up a 2.5 part per million dose in water that you have collected. And there are multiple charts. The blue line is for liters or cubic meters, and the green line is for gallons of water. The first two lines are for small volumes of water, 30 liters, say to 8 gallons, or for very large volumes, the last two lines on the bottom are for something like a cistern or a storage tank. And they go up to 30,000 liters or 8,000 gallons on this chart. So we have a 5-gallon bucket. We go back here on the green line to 5 gallons, go up, and we're going over to about 9 to 10 milliliters of solution that we're going to put of the disinfectant into the water we've collected. So you begin by removing the syringe from the packaging, and then we close the syringe, insert it in the oxidant, and draw oxidant into the syringe. After you've drawn oxidant into the syringe, then you push out the excess oxidant down to the volume that we selected on the chart, in this case about 10 milliliters. You then take that and add that solution to the water you've collected that you want to treat. We're now going to check the chlorine content of the finished water to make sure it has a chlorine value in it. But first you have to let the water sit for about 30 minutes with the disinfectant in it to make sure that all the microorganisms have been killed. So you begin by taking a test strip from the container, stirring it in the water, and you will notice that the pad is green and it's in the OK range, so you now have chlorine disinfectant in that finished water and it's safe to drink. One of the maintenance procedures that may be required periodically is to clean the system, and it's primarily from contamination from carbonate scale, calcium carbonate. Calcium may be in the source water, like in a well application, or it may be contaminants in the salt. In any event, it's a very simple process to clean the system. So you simply add vinegar to a container, and it's just common vinegar. It can be any type of vinegar. You put the brine suction filter in the vinegar, and you put the discard hose, the disinfectant hose, in the same container. Basically what we're going to do is circulate the vinegar through the system. We do that by turning on the system and letting it run until it faults out. Since there's no salt in the vinegar, the system is going to run until it faults out for low salt condition, and the light will come on. So you let it run until the light comes on, and then you simply turn off the system and turn it back on and run it for 3 cycles like that. And after 3 cycles, the system will be clean from any carbonate scale. The reason that you acid wash the system is due to carbonate scale buildup in either the fittings or in the tubing. How often that occurs or how often you need to clean it is dependent on how much carbonate scale is in the source water or is in the salt. But typically you'll see a cloudy appearance showing in the discard tubing. The other way that you'll know that it's failed is when the thermal well shuts the system down because of too much blockage of calcium carbonate in the piping or in the tubing. This maintenance procedure involves replacing the tubing in the peristaltic pump. This is not something you have to do very often, but when the pump begins operating funny or you get a leak in the tubing, you'll need to replace the tubing. This system comes with replacement tubing and also replacement tie straps that you put on the tubing connections. So you simply snap the top of the cap off, you remove the peristaltic tubing with the cam wheel, and you remove the tubing off of the fitting, off the gray fitting here. You may need to clip the tie wraps off of each of them, but you need to be sure and put the blue tie wrap on the blue hose when you put it back together. The Stream system is designed to be very robust. All of the components in the system are waterproof. You can basically operate this with the lid open in a rainstorm. It's also designed to be very strong from the standpoint you could drop it on concrete and it won't come apart. It's basically built to military standards. If you operate this system for 24 hours, it'll produce enough disinfectant to treat 60,000 gallons of water a day of drinking water. 60,000 gallons is equivalent to about a large family swimming pool. So after you've operated the system, if you're not going to use it for a while, then you need to store it away properly. So the first step is to unplug it from the wall. So you basically loop the power cord back on itself, and you take the Velcro strap and you loop it around, put it through the loop, tighten it up, Velcro, and now it's stored away. The next step is to connect the two hoses back together. And the reason we're going to connect the hoses back together is to make sure that no fluid that's in the hoses or in the cell can get into the system. So we disconnect the filter from the brine hose and we connect the two hoses back together. The next step is to loop the two hoses together in coils, pull it together, and then tie it together with a Velcro strap and place it in the control box. The last step in the process is to store the brine filter in its container, put the lid back on it, secure it fairly tight, put it in the storage pouch, put all the other contents in the storage pouch, the charger adapter, and the mixing cup, and zip the bag up. You also place in the 12-volt power cable in the case. Close the lid, snap the clips, and it's ready to go. If you have any questions, you can look us up on our website and contact us by email or our phone numbers, or you can contact your local distributor.